All right, so we're back. We did these notation terms, okay? That also is super important that we understand those, okay? And then some of the rules we learned were like derivative of, let me get blue here, or sorry, purple, okay? Derivative, I'm going to abbreviate, of sine. We also did derivative of cosine, okay? We did derivative. What are some other weird ones that we did? Or different ones? We did tangent. What else? Well, not ln, what's it called? Natural log. We had deriv of natural log of x. Okay. We also had e of x. Am I missing any? I don't think I am.
I mean, if you count secant and cosecant.
We'll actually leave those off because those are just that gets more complicated. I want you to have these three memorized, so that's why I left them on there. All right. Okay. So we'll go ahead and circle those. Okay. I would love for y'all to have sine and cosine memorized. Yep. Awesome with that. Okay, I did mine in purple. So we can start to see the different categories here. All right. And then, I'll catch up to that, sorry. Awesome. Okay, great. Different words. Awesome. All right, and then the last corner here are different processes. What are some of the processes we've learned? Like we learned the power rule. I'll give you a start there. What are some other ones we learned? Let's hear some more, guys. Quotient rule, I love it. Chain rule, I heard a couple say chain rule. What else? And the product rule. Okay. Excellent.
Special ones.
Excellent, excellent, excellent. Okay? Excellent. Looks good. All right? These are the basic things that we've learned. Am I missing anything new? Is there something that someone's thinking of that I missed? Chris, you had one? Okay, I thought you had one. No big deal. Okay, so what we want to do here, and I see some people are still writing, so I'll talk slowly. Okay, yes, Jonathan? Where we expand, that's a good point. We do expand sometimes, and we do simplify. Okay, so I'll put expanding here. Excellent. All right. What we want to do is we want to give some examples. Okay, so I might show, like here, when I have two things being multiplied, I might show an example, and I might say x squared times sine x. That's an example of a problem where I have to use the power rule. I'm sorry, not the power rule. That's supposed to be product rule. My mistake, guys. Let's put that under product rule. Because those two things are being multiplied together, so I have to use the product rule. I put x squared times sine x. Let me zoom in a little bit for you. Okay? Under our processes and under our rules, if y'all could just write the rules or the examples right here for processes. So give me an example of a quotient rule or a chain rule problem. Give me an example of when I would expand, okay, and when I would use the power rule. And then I want you guys to show me what are the actual derivatives of e of x and natural log of x. Actually write them there next to the bubble so you know what they are. So can I get someone to explain what we're about to do? Let's go. Let's hear from Natalie. What are we about to do?
We're gonna write examples for all of the little terms.
Okay, and then great. So go ahead and do that. Take 2 minutes to do that. You can talk to someone next to you if you need help. Take 2 minutes to zoom out. You said to go ahead and show examples for each of these. Okay, and then the rules. I want y'all to actually show the rules. Go ahead and try that right now. 2 minutes. What's that? That's okay. So just put them like kind of like small on the side there. Yeah, if you want. Just try to keep it neat and organized so you know. Okay. This will help you study later because then you'll be able to study all the different rules that you need to know. Okay. Oh, minus. Because it's where you have two things being divided. to make this a little bit more concrete, I would actually put an x right there, make it 5x, because then you definitely have to use the quotient rule. And William, all we're doing is we just finished writing out the rules, and then you are just going to put an example next to each one. Okay, sound good? Martha can help you if you need it. Yeah, for chain rule, there was a couple of examples. Okay, there's a couple of examples you can use. Try to use one that will help you remember which one.
That's right.
I'm sorry? You're not sure what the example for a chain rule expanding is? We did some in our notes, but the main thing is a chain rule is when you have something, a function inside of another function, like sine of 2x, or e to the 2x. For expanding, that's when we had like this 2 parentheses to the squared, and we could just expand it and take the derivative. Okay? And we did a couple examples the other day if you want to look at them. Great. Take about another 30 seconds to try to get some examples out. Okay, I see a lot of people are looking back at their notes. Some people looking back at their notes of examples. Let's actually take 1 more minute. I think we need 1 more minute because some people are still working on this. Okay, I see David actually wrote out the rules for a quotient rule. That's great. Okay, I see Shalia has lots of examples next to hers. Diego's writing them out. Great. Caesar's looking back at his notes. William's thinking about which ones to put next to it. Thank you, William. Cool. Excellent. These look good.
Power rule, would that be e to the x minus?
Power rule is when you have like x squared becomes 2x. It's simpler than that. Great. Maybe about 30 more seconds now. Give you all a little extra time because people are still working. Okay. All right. All right, guys, let's go ahead and bring it back together. Okay? I want to now start drawing connections between some of our concept map words here. Okay, I'm going to draw some connections. How many of you guys have done concept maps in your other classes? I just want to make sure I understand that y'all are familiar with this. I thought so. Okay, great. Okay, so just making sure. Okay, so one I'm going to choose is like a concept. I'll show a concept category like over here with the tangent line problem, and then we'll do one over here with processes. Okay, so I know that we use the secant line because why? I'm going to draw a connection there. Why did we use the secant line? Why were we using the secant line? Does anyone remember? Rihanna? Yeah, why couldn't we find the slope of the tangent line? Okay, why, Chris?
Well, there's only 1 point.
Okay, so we can draw a connection and just write what the connection is. We use the secant because it had 2 points. That's why we used it. And the tangent line only had 1. So that's why I draw my connection to it. So we use the secant line for the tangent line because the secant line had 2 points. I drew that connection to show that's how those two things were related. So we use the secant because, and I'll zoom in here, because it had 2 points. Okay? The tangent line only had 1. All right? So that's how I can draw a connection there. I want to actually draw the connection and explain what the connection is. Okay, if I draw a random line, that doesn't help me. Right? I actually want to explain what the connection is. Okay? Any questions there? All right? And you're going to have to be a little creative. Not all of them are going to be super logical, so you're going to have to be creative here. Okay? Now, I might draw, okay, a connection between these, okay, all 3 of those together. How are all those 3 related? Why did I draw a connection between dy dx, f prime of x, and y prime? Why did I do that? Someone raise their hand and tell me. Caesar? They all, what do they mean? Yeah, they all signify that we're using the derivative. So we can write, they all, okay, mean derivative equation. And I actually expanded my explanation to cover both those lines there to connect them all three. Okay, so that's how we can connect those concepts. Like those are how those are related. Okay, if you're not sure what a word means, you may need to ask someone around you. We want to try to get connections for each of the words. Okay, let's do one that involves a process or a rule so that we understand how to do those. Okay, all right. So I might connect, for instance, I might connect the quotient and the product rule. How are the quotient and the product rule related? How are they related? What happens when I do them?
You're expanding.
You-
Like remember we did the three things on that vector?
Mm-hmm. It's not expanding, but what happens when I take the quotient of the product? Well, what happens to my equation? It gets a lot bigger, right? Because you have to do the f prime and the g prime and the f. Okay, so they both involve f prime g and g f prime. Or sorry, f g prime, my bad. Okay, they both involve those two terms. Okay, quotient rule subtracts it, product rule adds it, but they both involve those two terms. Okay? Alright, so what I want y'all to do is try to make connections in each of the categories. Try to think of how they're related. You could also, if you want to be super creative, you could actually go across categories here. Okay? So for instance, I might connect a tangent line with something in another category if I feel like it's relevant. But we want to spend about 10 minutes, and I want y'all to get connections for each of the words, okay, as best as you can. If you're not sure what to do, don't just draw a connection and write something random. Try to ask someone around you what they connected. It may be simple as, like, these are all rules we use when the derivative is complicated or something like that. Mia had a question? Okay. Or you could also connect it back to the derivative in the very center. Don't forget about that one. Okay? Go ahead and work with your people around you. Let's take about 10 minutes. We're going to draw connections between all of these words. Go ahead and draw connections between all of these words. And I'll tell you what we're doing afterwards.
I ain't got no space.
That earthquake drill tired y'all out? Is that what happened? Yeah, please put your name on it. Try to draw a connection. I see David drawing connections between the tangent line problem words. Yes. Take your hood off, please, David.
We don't have enough time to finish our presentation. Will we do it?
Oh, yeah, we'll get there. Yeah, we should have enough time to do most of the problems. Okay. Okay. Try to draw some connections. You may not get all of them done in this moment, but try to just start. You can also draw a connection about how they're different if they're not super related. Okay, maybe also tell me how they're different. Oh, nice. I like that, William. William has a good connection there. You guys talk to each other. You can look at your notes. That's a good connection, William.
What was it, bro?
I did see. You were writing how use differentiate to find the tangent line or the slope of a curve. Good job. Good job. I like it. Try to think of some connections best you can. What are things that are related on here? How are derivative of sine and derivative of cosine related? Great. Try to think of some connections as best you can. It means take the derivative. So those differentiate and derive are similar words. Okay, some of you already understand your page. Try to think of some of the connections you have. You can ask someone around you for a similar connection. Okay, it may just be as simple as connecting words, where you're doing it like these are all related because it's all derivative of trig functions. You know, or you might connect these two because they're special derivatives that have similar. That they're similar equations, they're inverse equations, okay? So you want to think about how you can connect some of these together. They may be simple connections, but you want to think about, okay, how are these related? Yes. You have to think a little bit. Thinking is good for you. David has a lot of good connections. You could ask him. Deja has a few good connections. Okay. I see Shalia up here connecting some words. You can do it. So like, how are expanding and power rule related? Oh, sorry, expanding and product rule related.
You expand.
Remember, expanding was like an alternative to the power rule. It's like we could just expand it out rather than like having to like do the product rule where you multiply them together. Okay. All right. Take about 4 minutes, make as many connections as you can. If nothing else, we've categorized these things really well. Okay. And we'll be able to use the categories to help us study. We'll be able to use this sheet to help you study some of these processes. Okay. Try to think of some connections here. These are good. Those are good. Like how are these two related? Like e of x and natural log of x are actually inverses. Okay. So they give you like derivatives that are just weird. Like if nothing else, they're just like weird derivatives. Like this one's what?
It's just 1 over x.
1 over x, right? And this one's what?
E to the x.
Yeah. So it's just kind of like they're strange. They're special derivatives. Okay. Look at your notes. Oh, who asked that? Sorry. It came from like right here. You look at your notes. Look at your notes. How's yours coming?
He's helping me. I don't understand that one.
Well, what do all these terms mean? We actually went over it up here. What do they all mean, Kerwin? All right, about 3 more minutes. Okay. You are welcome to go find someone who has a connection that you might want to try to use. Okay. I'm sorry. You want to be sure that you are on task if you do so. Oh, I don't have any. That's why I didn't give you one. I don't have any. I'm sorry. Guys, stay focused, please. Try to think about some of the connections you see. Okay? Y'all are just staring at your paper. Stop staring at your papers and actually draw connections. Okay? And think about how they're related. They may be as simple as these are complicated. Alright? These deal with multiplication. Okay? These are just strange derivatives. Okay? These two words mean to do the same thing. There are different connections you can do. Try to draw some out. I'll tell you in a second.
We have to make two.
I'm going to explain in a second. Just put it to the side. Try to think of which other ones are related. Why are you all just staring at it? Like, draw a line. Huh?
Staring at me. I don't know what to say.
Okay. So, how is the... Like, what? How are all these related?
Which one is this one again?
The power rule? You need to look it up. It's where you have to... It's the very first one we learned. The very first one we learned. But, like, how are... Like, for instance... These two words mean to do what?
Find the derivative.
Yeah, so write that there. Great.
I'd say similar.
Okay, as long as you know what that means. And then, like, how are... Like, for instance, the chain rule, how's that related, okay, to, like, the power rule? Or, yeah, how's it related to the power
I'm
rule?
not really familiar with the power rule.
You might want to look it up.
200.
All right, guys, take one more minute. We're going to go 1 minute over, then we're going to do our next activity. 1 more minute, and then we'll do our next activity. Y'all have a seat. Y'all can't handle it. Have a seat. I did. It had nothing to do with this concept map. Have a seat, David. Keep working. Okay. All right, guys. Let's go and bring that together. Some of y'all are still struggling. Okay. That's okay. You're still, as long as you're thinking about what these words mean. Okay. And start thinking about how they are related. Let's go ahead and bring it back together. Okay. All right. Can I get just a couple of volunteers to describe some of the connections they made and what they were? Go ahead, Caesar.
I did expanding and particle.
Okay.
They're alternative.
Okay.
I said particle. You put power.
Oh, I'm sorry. I did that again. Okay. These are alternative methods. Tell me what you mean by that.
When you can like use the method.
Yeah, like you can, we saw the other day that if we don't want to use the product rule, we can actually just expand it out and then take the derivative. Okay? What else y'all got? Go ahead.
The tangent line helps you find the slope of it.
Yeah. Okay. Great. And then how does derivative relate to these words up here?
It relates to everything.
How so?
Because all that has to, all the words that you have to use the derivative in some way. Or you have to use like the tangent line,
Uh-huh.
and it'll get you to the derivative.
Or I think you have it backwards. Okay? I see what you're trying to say. The derivative will help us to do what, William? You had it on your paper. You did a beautiful job. What did you say?
I put for slope of a curve.
Go ahead.
You have to, with the slope of the curve is basically the first part, right? You want to find the slope. And then you
Stop talking in the back. Okay?
I don't mind.
So, it helps you find...
Like it all works.
Okay? Great. So it helps you find the slope of the curve. Let's get one more connection someone made. I'll call on people I saw, or you can just go volunteer. David? They're all trig functions. And what's special about, so I'll go ahead and write that. So these are trig and trig. What's special about sine and cosine though? They're like not the inverse, like just, they're opposites, and we can also say opposite signs too. Okay? So opposite and opposite signs. Okay? Because derivative cosine is negative sine. Yep. All right? Good. Awesome. All right. So we'll pause there. The reason why I want you all to do this is so you can fold it in half and you have a study guide of the concepts we've learned. Okay? The biggest thing I want you all to focus on Okay? You need to understand what these terms mean, so when you see them, you know what you're supposed to do. Okay? You want to understand what rules to use and processes to use when. Okay? You need to have these memorized, but you need to know when to use these. Like, when do I use a chain rule instead of the quotient rule? When do I use quotient rule instead of the product rule? Okay? And we've seen a lot of problems where we've had to figure out first what we're going to use. Please stop talking. Okay? Yes?
For the product rule and the chain rule, can't sometimes use either or, depending on how high the exponent is.
What do y'all think?
I'm asking you, so.
Why is that? Why do you say yes, Natalie?
Because like it's a, like when we had the like the little package you gave us on Tuesday,
Mm-hmm.
it showed the 3 different rules, and it was like the exact same equation.
Right. And any of them worked. One was more convenient than the other, but any of them worked. Okay? All right, what I would like for y'all to do is I would like for y'all to fold this in half. Okay? I'm going to grab a few of them, scan them, and give them back to you. All right?